This is section 2-4 in the Big Ideas book. Today we're talking about solving multi-step inequalities. Inequalities, again, where there's more than one step. What do we mean by an inequality? We're basically talking about that one side is not equivalent to the other. So what we're saying is this half of the inequality is not equivalent to this half. So, and what it's really saying is that the first half is smaller than the bigger half. So that we should have already gone through. So when we're solving a multi-step inequality, the first thing you want to think about is it's just like an equation. So we solve by undoing our addition and subtraction first. So it's always easier, otherwise we'll create a fraction. So to undo our addition and subtraction, we're going to have to undo that minus 5 by doing the opposite, which is plus 5. So I hit the plus 5, add 5 to both sides, and we end up with the quantity of 2x is less than 16. Divide both sides by 2. And we are left with x is less than 8. Now when we have an inequality, we have to graph it. We have to graph it because it's not just one solution. And if we have to list every number less than 8, that's going to take us an eternity. So the easier way to do it is to create a graph. You need a number line with whatever number you're graphing. That would be 8. And you need to show it in comparison to 0, where 0 is on the number line. So I want to see two numbers, 0, whatever number you're graphing. So in this case, it's 0 and 8. Because it's just less than, it's an open circle. If it included the 8, it would be a solid circle. And to show the numbers getting less than 8, we go in the left direction because they're smaller than 8 on the number line going to the left. So the things you have to remember is that you need arrows on both the number line and on that one little red line. You need an arrow going in one direction. If you don't, I will mark it off because it would just stop at wherever the line stopped if you didn't have the arrow. That arrow means it goes on and on forever in that direction. The open circle represents it does not include 8 in that number set. The numbers in that number set that are less than 8 start just smaller than 8, but not including 8. So now I'd like you to pause the recording and try the next one on your own. All right, so for the next one, to undo the addition and subtraction first, we have to add 4 to both sides. Then we end up with 3x is greater than 21. Divide both sides by 3. And we are left with x is greater than or equal to 7. All right, so now you have to graph it. And so we need our number line. Our number line should have two numbers, 0 and positive 7. And then this time, because it has the little equal sign line underneath the arrow, that means greater than or equal to. That little line underneath means equal to. That includes the 7 in the number set. So we have the entire 7, it's greater than or equal to, and the numbers getting bigger than 7 are to the right of 7 on the number line. The next one, number 2. Pause the recording and try that one as well. All right, so first, to undo our addition and subtraction first, we're going to add 5. Now I have x divided by 2 is less than 8. The inverse operation of dividing by 2 would be multiplying by 2. So I multiplied both sides by 2. Remember, when you are multiplying, you're really multiplying by 2 over 1. Either line it up with the numerator, which is kind of hard to do with PowerPoint, and put it over 1, because otherwise, if you line it with the denominator, I will mark that wrong. That would end up being 2 times 2. When it's lined up with the numerator, you can cross cancel, and you are left with 1x over 1, which is just x is less than 16. And then we create our number line. We have to read from our variable. Since our variable is on the left, we need 0 and we need 16. We are starting at the 16. That is our starting point. Because there is no equal to underneath the arrow, it's going to be an open circle, and it reads x is less than 16, so it goes to the left. Because the numbers get smaller, less than 16, to the left. All right. Number 3 and 4. So in other multi-step situations, number 3 doesn't really look like 1. Why don't you pause it and try and do that one next? Okay, great. Now the easiest piece to undo is that 7. And that 7, it's not written there, but remember the sign is always to the left. So we are going to do the inverse of that positive 7 and make it minus 7. Then I'm left with negative x is greater than negative 3. What do we do next? We have to isolate that x and get rid of that negative 1. It's not written there, but that negative really implies it's a negative 1. So to get rid of negative 1, we can do one of two things. The inverse would be to divide by negative 1. Now, when we are dividing by a negative or multiplying, in this case only with negative 1, we can divide or multiply by a negative. This is the only situation where you don't have to use the inverse, the opposite operation. When you divide by a negative, remember, you have to flip the directionality of your inequality. So instead of it being greater than, it's going to be less than, and I get negative 1 divided by negative 1 is just going to be our x left over. Negative 3 divided by negative 1 is positive 3, and I graph it. So one more time, remember when I divide or multiply by a negative on both sides, we have to switch the directionality of the inequality. And then we graph, we say x is less than, so we're going in this direction. All right, pause it and try number 4. Now, when we do number 4, the first step we have to do is, well, you could actually do this in a couple different ways. We could distribute and then solve it, or notice I have 3 times a quantity. I could actually just divide both sides by 3, and now I'm left with x minus 5 is greater than or equal to 4. Add 5 to both sides. And we are left with x is less than or equal to 9. Okay, and then we would have to graph. I need 0 and 9. I'm starting at the 9. It should be a solid circle because it includes 9 in the number set, and I have to go into the less than or equal to. One more way to solve it would be to, if I just distribute right in, whatever's easier for you, 3x minus 15 is less than or equal to 12. I'm adding 15, and I'm left with 3x is less than or equal to 27 divided by 3, and x is less than or equal to 9. So yeah, we have the same thing, 2 different methods. I've got my 0, my 9, and I start. Make sure you, and always make sure to have an arrow at the end of that line. If you notice in my graph, in my PowerPoint here, like I said, when I have -1 as the coefficient of x, that's the only one I can multiply by. I don't have to do the inverse and divide by -1. And so our problems just get longer. On the next one, why don't you pause the next two, do them, and then check your answers. All right, now check your work. Distribute, subtract 12. Notice I've got -3x is greater than -21. Divide both sides by -3. Because I'm dividing by that negative, I have to flip the inequality, and then we graph it. The next one, I'm moving my x's all to one side, so I'm adding 2x. Now I'm going to add 3 to both sides, divide by 6, and I am left with x is greater than, reduce it, and we have -2 1/3, -2 1/3, and then we graph. Remember, it's going to be greater than. It may be easier for you to convert that 7/3 to a mixed number in this case, so you know where it's at in the number line. All right, so now we've got some word problems. And we've got to remember, we're still doing the same things when we do our word problems, because basically we want to build ourselves so that we can write an equation for any word problem. So we want to still identify our unknowns. Joe is saving for a new bike, a new $500 bike. He currently has $125. If he saves $15 per week, how long must he wait to save at least $600 to cover tax and extras? So the first thing we need to do is define our unknown. Our unknown, what's changing, is the number of weeks. So our number of weeks is changing because we need to know how many weeks, how long it's saying. That's one clue as to what your unknown is, how long. Okay, and it really kind of gives it to us. 125 is what he has, and he saves 15 per week. There's my variable, and it has to be at least 600. So we said our unknown is weeks, so I'm going to call it W, stands for weeks. And now I can write my equation. He's starting with the 125 plus he's going to have a $15 per week, and now it has to be at least. If I say you have to be at least 16 to drive, that means you can be 16 or older. So at least would have to be, all of this has to be at least, it has to be greater than. Again, you have to be 16 or older, so it would be greater than 16, or it could equal. And then we have our ending. Remember, at least is greater than or equal to. And now we can subtract our 125. Got 15W is greater than or equal to 475. I'm dividing both sides by 15. And we get W is greater than or equal to 15 goes into 3 times 2 times. So we want to get this exact. So make sure you're following your, we've got 3 times. Oops, I made a mistake here. Still going. I have a remainder of 2. It goes 1 time. If you kept going with the division, you'd get 0.66 repeated, and we get x is greater than or equal to 31 2/3. Now remember, how many weeks? The question is, how long must he wait? So make sense of it. It's at least, you can't do a part of a week. It said how many weeks. So you have to round up to that 32 weeks. Because it says how long, how many weeks, or he doesn't get his savings, his money halfway through the week. All right, here's another one. A water tank contains 500 gallons of water and begins leaking at a rate of 4 gallons per minute. So, our unknown. Because the tank must be repaired from the inside, it can retain at most 60 gallons of water. How long must the repairman wait to fix the tank? So a water tank contains 500 gallons of water and begins leaking at a rate of 4 gallons per minute. Because the tank must be repaired from the inside, it can retain at most. So we're starting with x is our number of minutes. Again, how's your clue for what the unknown is? It's the how long is telling you what our x should stand for. So if I have how long, I've got my 500 gallons of water, and it's 4 gallons per minute. Let me underline that for you guys. I probably jumped ahead. I've got 500, then you've got 500, 4 gallons per minute. That's what we're starting with. This is what it's leaking at, and we know that it has to be less than or equal to 60 for him to work on it. We want it to be subtracting because we want it to empty out. We're going to subtract 500. I'm left with negative 4x is less than or equal to 440. Divide both sides. Remember, when we divide by a negative, we have to flip the inequality. And we are left with x is greater than 110. Now, take it back to the story. What does that mean? That means it has to be at least greater than or equal to is at least 110 minutes. All right, I can guarantee this will come up. It will be on a test, so please know how to do the averages. Heather received grades of 80, 75, 86 on 3 algebra tests. What must her grades be on the next test if her average of 4 tests is to be at least 82%? So what is our unknown? Step 1, our unknown is the last test. We're going to say X stands for the last test. So to find out our average, we have to add all of the tests up, plus that last test. And remember, to find an average, we divide by the number of tests. 1, 2, 3, 4. It has to be less than or equal to be at least, so it must be greater than or equal to 82. She needs an 82 in the class. So I add them up. 80 is 160, 170, 1 plus 241, 80, 70, and 8, 160, and 70 is 230, 241 divided by 4 is greater than or equal to 82. Plus x. Okay, so step 1, let's clear our denominator. Fractions are always difficult to deal with, so we're going to multiply both sides by 4. And when I do that, I get 241 plus x is greater than or equal to 8 and 32. Subtract 241, subtract 241, and we get x is greater than or equal to 8 minus 1 is 7, So my answer is x must be greater than or equal to 87. What does that mean? If you take it back to the story, she has to have at least an 87 to score an 82 in the class. Okay, this is the last problem for the day. So, the sum of 3 consecutive odd integers is less than 100. What are the greatest possible values of these integers? So our first step, as usual, is to define your unknowns. What are we going to call our first integer? It's actually our first odd integer. So we don't know what it is, so we are going to call it x. And the next odd integer, remember if it's on the number line, if they're odd numbers, if this is x, so if this is an odd number, this would be an even. To get to that next odd, you would have to jump 2. So we're going to call it x plus 2 is the second odd integer. Okay. And the next one, from that original one we called x, we're going to have to call x plus 4. So that will be our third odd integer. And so now we're going to do the sum of 3 consecutive odd integers, x plus 2 plus x plus 4 is less than 100. What are the greatest possible values of these integers? So I combine my like terms. 3x plus 6 is less than 100. Subtract our 6. We get 3x is less than 94. Divide both sides by 3. And we end up with x is less than 31 and 0.3 repeated. Now we have to make sense of what we came up with. Here's the thing. They want the greatest possible values of these integers. The question is 31 and 0.3 repeated, is that an integer? If you remember from our groups of numbers, our integers are positive or negative whole numbers. So x has to be the closest odd integer to 31.3 would be 31. It's the closest integer. Less than 31.3, so I would go to the closest integer, and the next one would be 33, and the next one would be 35. And so the question is, what are the greatest possible values of these integers? They would be 31, 33, and 35. And this is where we get you when kids are not reading the language of the integers. And that is your lesson on multi-step equations. That's it.